what I wanted to talk about today was take a kind of a review so far of what we've seen, and kind of focus in on the kind of the three storms that have really kind of impacted the U.S. the most. I didn't touch on Hannah. Hannah was kind of more of a system that impacted extreme southern part of Texas and into Mexico. So I'm hitting more on the other ones, and of course Laura and Sally were more recent. Isaias went directly over us in early August and had a pretty big impact. Then we're going to take a look at the outlook kind of for the rest of the season, and not only look at what the outlook is, but also look at kind of some of the tools and maybe why we've seen some of the some of the storms that we've seen, why we've found them this year. There have been a lot of technological advancements in the last probably 4 or 5 years that have really aided the hurricane forecasters in identifying some of these storms. So we're going to look at some of that. And then lastly, I want to take a few minutes to focus in on storm surge, because storm surge is one of those unique elements that we deal with tropical systems that I think not necessarily everybody truly understands what exactly it means when we're talking about storm surge, and why it can be so vary so greatly between storms and between locations. When we look back at, we're going to jump right in here to Isaias. You can notice as we look at the storm names, this was the list of we were supposed to be using this year, and we've gotten all the way through Wilfred already, and now we've jumped into the Greek alphabet. This is only the second time that I can remember that this happening. The last time was 2005. We ended up getting through 27, so I think we made it down to Zeta that year. So right now we're at Beta, and we got 4 to go to get there. So, and we still have time, and we'll take a look at the some of the climatological stuff as well to look at that here in a little bit. So, but these are your names, and typically we don't get all the way through the list, but this year we have. When we look back at Isaias, this was from August 3rd and 4th of this year, so early August. Made landfall down near Wilmington, North Carolina, and then moved quickly northward through eastern North Carolina and eastern Virginia before heading up the coast. And this was the rainfall that we saw with this event. And the good thing was we'd been fairly dry before this. The months late June and much of July had been fairly dry across the mid-Atlantic states. As a matter of fact, we even had on the U.S. Drought Monitor, we had some abnormally dry markings, areas denoted as abnormally dry on those maps. And I think we even had one area that was in moderate drought on the Delmarva. So the dry conditions initially helped us because we didn't see really a lot of flooding out of Isaias, despite the fact that we got 3 to 5 inches of rain in about a 6 to 8 hour period as the storm moved through. So, but the thing that we saw with this one, this is kind of what we expected. As the storm came northward, the precipitation swaths shifted and ended up being on the northwest side of the storm. And that's typical with these systems because as they come northward, the moisture gets kind of usually thrown back. Usually there's some drier air that tends to be on the northwest side. And so as the moisture gets thrown into that, we tend to see these broader, more widespread rain patterns. And that's what we saw here as well, where the rain was on the kind of the north and western side of the track. The eastern side of the track, notice there wasn't quite as much, and part of it was because you weren't dealing with the persistent rainfall, but it was more intermittent bands of rain going through. And but with that said, the other impacts with the storm were greater on that eastern side. That's where your wind was much stronger. We had gusts anywhere from 50 to 70 miles an hour, on the eastern side, really, especially in the coastal areas and on the bay. So there was a lot of wind on the east side, the heavier, a little bit more stable conditions on the west side. So kind of the trade-off as we're dealing with these storms as far as kind of the impacts from them. The other big impact that we saw from Isaias was tornadic activity. This was one of the largest tornado outbreaks that from one of these tropical systems that I've seen. I know there have been several documented cases from back in 2004, which is another very active year, from storms like Ivan that year that had a lot of tornadic activity. Sometimes the tropical systems come in and they don't have much tornadic activity at all. But this one definitely did, and I think some of it had to do with the fact that we were seeing the system start to make the transition from being a purely tropical system to start transitioning more to a extratropical or mid-latitude type cyclone, where you start getting drier air pushing in and different, some jet stream influence and things like that, things that help develop, the more mid-latitude cyclones that we see throughout the year. And that seems to have been a trend, especially in the mid-Atlantic, that we see quite a bit. In this case, I think it led to a little bit more of the tornadic activity developing. So you can see we had 7 in Virginia, 5 in Maryland, and 3 down in North Carolina. One of the ones in North Carolina, in eastern North Carolina, in Bertie County, was the EF3 tornado. And that was one of only 4 EF3s that we've recorded from tropical systems in the Atlantic basin. So, and I think the last one had been back in 2004. So, that one was pretty substantial, and unfortunately there was a fatality with that one as well. The image that you're seeing here, the picture, this was some drone footage we got of. I was actually up in on Maryland on the Eastern Shore in Stockton, but you can see the damage path with this is very clearly laid out with this drone footage. And you can see how you're getting the convergent pattern in the damage. You can see it even in the back in the tree lines as it was going through, how it was just stretching the debris. And one radar, we were able to actually see the what we call now the debris ball. It's one of the improvements in the Doppler radar. We were actually able to see the debris ball with this. So that really gave us strong indication that we had a tornado on the ground at that point. So this one here was rated as an EF2. So it had winds around, I think we estimate around 120 miles an hour. So, very significant damage. And, 15 of these, and they all occurred in the early morning hours. So most of them had occurred by 8 o'clock in the morning, kind of between 2 a.m. and 8 a.m., which is not a normal time when you would expect to see tornadic activity. But that's when it develops. So, Isaias had even though it was only a tropical storm moving through our area, it came ashore as a kind of a minimal hurricane around 75, 80 miles an hour as Cat 1, but it still had quite a punch as it moved through. Let's jump ahead to kind of the end of the month now, and we'll take a quick look at Laura. Laura was the strongest hurricane we've had so far this season as far as the wind speed went, and it was still intensifying as it made landfall. The pressure was down in the 930 millibar range. I think I saw one recon report that was down around 935 millibars not long before landfall. So very powerful storm. You had wind speeds, significant wind speeds up to 130 miles an hour as it came inland. The interesting thing that I found with this one was the fact that how quickly it weakened. Once it got across Louisiana and Arkansas, it really kind of weakened, and the rainfall amounts dropped off pretty quickly. And once it started to make the turn to come east, we were anticipating much larger impacts in Virginia than we actually got. And by the time it got to us, really we had a little bit of a enhancement in the breeze, and there were a few light showers around, but nothing kind of that we would have anticipated that the system would have been when it made landfall 2 days earlier. So that was one of the things that I noted with this system. You can see on the rainfall map here, you really had the heavy rainfall right along the track, anywhere from 5 to 10, maybe up to 12 inches of rainfall right along the track across kind of central and western Louisiana, and that continued up into Arkansas. But you see it kind of tapers off very quickly. The part that I found interesting was more in the kind of in the Mississippi area, how once it came inland and got away from the shore, the areas east of the system didn't see that much rainfall. So it really kind of dropped off. So it really became very narrow along the path of the storm as it moved inland. And some of that may have had to do with a lack of a moisture feed. One of the things that we get on the Atlantic a lot of times as these are coming inland is they still have a really strong feed of moisture coming in off the Atlantic. And on the Gulf Coast now, once they kind of get inland a little bit, they really, they're getting away from the Gulf and they lose the moisture feed. So, so that was kind of one of the things that was kind of interesting in the precip pattern there. Looking at the wind, this was one of the images that for me was interesting, was the damage that occurred to the Doppler radar. We have in Wakefield, we have the same radar sitting right outside our door, and most of the Weather Service offices have the radar co-located. There are a few offices that where the radar's a little bit away from the office. But you can see in the imagery, you can see on the left-hand side what it's supposed to look like. And if anybody has driven down 460 past our office, you've seen the golf ball sitting there. Well, the image to the right is what it looked like after Laura had gone through. So the antenna inside completely gone. The entire golf ball just completely opened up. So I'm not sure how long it's going to take to replace it, but it will definitely be some time to replace the entire radar. So that's definitely not something I expected. But when I did look back, the radar stopped. As you can see, it says stopped at 12:53 a.m. And that was the same time that the Lake Charles Airport reported the 132-mile-an-hour wind gusts. So I guess it's not surprising that when those kind of winds are going through that you're going to have potentially some damage. And with the radar being, probably in the neighborhood of about 60 feet off the ground, maybe, the wind's probably maybe been a little bit tick higher. So it doesn't take much with those kind of wind speeds. Once you get wind inside, it's going to, literally just blow out the entire the radar there. Surge was another big thing. That was the thing that really got the big push with Laura, was the fact they were really discussing, potentially, life, unlivable storm surge coming in. So I went in and unfortunately, along the Gulf Coast where it came inland, probably where the peak surge was, there was no gauging. So the only way they're going to be able to verify that is to go back in and do high water marking and things like that. The Hurricane Center does do that. The local office usually will do that. I don't know in this case if the Lake Charles office was able to do that or not, since they actually had evacuated for their own safety. So in this image here, you can see the water level got to a little over 9 feet mean high water. When we look at trying to describe above ground level surge, which is what the Hurricane Center uses in tropical scenarios, that is pretty close. The closest that we can get is the datum called mean high water. And so they're pretty close together. So that's where we kind of came up with the value of about 9 foot of storm surge with this system. Now, this particular gauge was very close to the center. So once the center moved inland, you can see the water level really kind of dropped off pretty quickly. So it surged up pretty hard right around midnight, just after midnight. And then once the center went by, it really dropped off fairly quickly. So keep that in mind, though, when we look at Sally's surge things. There's one graph there that's showing a little bit different, and I think when you see it, you'll understand why. But again, still 9 foot of storm surge above ground is pretty significant amount of water coming inland. The likelihood that in Virginia we would see that is very, very small, just because of the coastline, and that's why I wanted to talk about surge a little bit toward the end. We move ahead a couple weeks, and then we had to deal with Sally. Sally formed kind of as a wave just off the southern coast of Florida, moved into the warm waters of the Gulf, and then continued to intensify as it moved toward the shore. And then, unfortunately for the folks in Alabama and the Florida Panhandle, it decided to stall and sit there for a couple of days and move very, very slowly. It was moving in some cases, at 2 miles an hour. Well, it's not covering much ground. And so, unfortunately, that left a lot of big-time impact. So you can see when we looked at Laura's rainfall, we were getting 10 inches. Well, some of that was limited because of the storm movement. Same with Isaias, where we were only dealing with 3 to 5 inches because of the rapid storm movement up the coast. For Sally, with it sitting there, we were dumping and we were seeing rainfall amounts of plus 20 inches down along the Gulf Coast. So again, speed of movement, big factor. But once it came inland, we again saw that transition, and you can kind of see it in the precipitation pattern into kind of western North Carolina and even into Georgia, even into southern Virginia, as the precip shifted once it got inland to more on getting onto that north and west side of the track. Again, very typical with these tropical systems once they move inland. And so as the storm moved northeastward, the amounts in central North Carolina and eastern North Carolina were actually less, even though they were kind of closer to what was the remnant center. And when you got a little bit more to the north side of it, that's when we saw the heavy rainfall kick in across portions of eastern Virginia, and that led to some river flooding and a lot of flash flooding down there. In some of those areas, kind of down in Surrey and Isle of Wight and those counties, those areas, they had significant rainfall several times from since Isaias came through forward in time. So they've had quite a bit of rain. So it didn't take much additional rainfall with this event to cause more flooding issues. Sally didn't have a ton of wind, unless you were right there along the coast. But the surge values were pretty good for a system that wasn't moving that fast. This was from Pensacola, and you can see this was you can see the gradual buildup, and this is the slow movement over a couple-day period where you can see the gradual buildup from the 14th into the 15th, and finally, as the system made landfall in the early morning hours of the 16th, we finally got the final big push that pushed it up to about 5.5 feet of storm surge in Pensacola. But then once it came inland, you can see again how it really drops off very, very quickly. So you didn't, like I said, because of the slow movement, we had a gradual buildup, and the water level kept going up, and then finally kind of the last big push to get it up to its peak at 5.6 feet. Now, take a look at this next one. This one here is from Weeks Bay, Mobile, Alabama, which is just to the west of the one we looked at in Pensacola. Notice the large drop that occurred as you moved into the early morning hours of the 16th. So the water levels had been building similar to what we saw with the Pensacola one, but then you saw the big dropout. And that big dropout tells me that as the center moved inland, it moved in to the east of this site. So the winds actually went to the north. And when the winds went north, it actually blew all the water out. So instead of having a big surge of water going up Mobile Bay, it blew it out. And then once the center got inland and the winds kind of relaxed, then you started getting the slosh effect. So there was still water trying to come on shore. And as the northerly winds weakened and the winds became more southwesterly to even southerly again, you started to see the water get pushed back inland again. So this kind of gives an indication, just looking at the tide data, of where the track of the storm was. So if the center had moved in just a little bit further to the west, you probably would have had a larger surges going out Mobile Bay, because you would have had the surge staying southerly the entire time period. Okay, so that's kind of a review of kind of the bigger name storms, bigger impact storms that we've had in 2020. Overall, there have been 9 storms that have made landfall on the U.S. coast this year, starting even as early as late May with Bertha moving inland in South Carolina. And then up through Beta. Beta was the 9th storm to make landfall. So right now, looking at climatology, we are coming off the peak. The peak of the hurricane season is typically around September the 10th. So we are coming off that peak, heading down. So hopefully that means the activity should be decreasing. And looking at some of the satellite imagery and things like that in the basin, it does look like right now, after a very active period we've had for about the first 2 weeks of September, things are kind of quieting down a little bit. However, we still have probably about 2.5, maybe 3 weeks to go in the kind of the more active part of the season. Typically, we get to about the middle of October. You can see that little peak in activity that kind of pokes back up right here. That's typically the kind of the last big push in the tropical system, especially for the U.S. A couple years ago, if you think about Michael was right in this time period. And then usually after that, we start getting so much more activity with the northern jet stream with energy coming down from Canada that it tends to suppress everything further to the south. So the Caribbean starts to become more active as we go through getting into October. The Cape Verde season, the waves coming off of Africa tend to diminish. And so we stop seeing that activity develop as it comes across, and the activity shifts more into the Caribbean and in the Gulf of Mexico as we get into early October, and then eventually just ends up kind of more down in the Caribbean, moving eastward, kind of toward Puerto Rico and those areas as we head into early November before the season winds down. just to give an idea of the return periods for hurricanes. Right now, the last hurricane to make landfall, or to have hurricane force conditions in the Virginia area, was Irene in 2011. So we've had tropical storms go through. Isaias is being a prime example. It didn't have winds that reached hurricane conditions. So we're now at about 9 years since we've actually had hurricane conditions in the area. The typical range is somewhere between 13 and 15 years. So you got to think, based upon climatology, that in the next 3 to 5 years, we're likely to see hurricane conditions somewhere along the Virginia coastline. So we'll have to keep that in mind. Of course, as far as impact goes, it really has to do with the direction that the storm moves, how it approaches the coast, things like that, as far as how bad the impacts can be. So that'll be something to watch. But just to kind of keep an eye that probably in the next 3 to 5 years, we can expect that we will see one of these systems move into the area. Okay, the outlook. And this came out actually about a month and a half ago now. They updated the forecast to 19 to 25 named storms. So we're at 23 now. So we've pretty much hit the forecast already, and we still have several weeks to go. Hurricanes would be 7 to 11, and we're in that range as well. The major hurricanes, we've only had 2 so far. Teddy and then Laura were the 2 major hurricanes. So right now we haven't quite hit that value yet that they forecasted. So, but this, it's just interesting how many named storms we've already had. In a lot of cases, how early we had them. We had 3 in May, so it was very early having stuff getting named. Taking a look from a historical perspective, and I think this kind of gets a little bit more, helps paint the picture a little bit on the actual season itself. Because one of the values that they use to kind of measure the strength of the season is this accumulated cyclone energy index. And what they do with it, and you kind of see at the bottom there, they sum the squares of the maximum sustained surface wind measured every 6 hours for all storms while they're at least tropical storm strength. Tropical storm strength basically being 40 miles an hour or higher. So, so that's the calculation that they're using. And the year that everybody's been comparing this to because of the number of storms is 2005, and 2005 actually had the pretty much the highest ranking that we've seen. It's right up in here. So it was, according to the index, it was over 250 in the accumulated index. Right now, we are nowhere close to that, even though their forecast in August started pushing anywhere from 150 to 200. We haven't gotten close to that yet. I took this image from yesterday, so it doesn't count anything that they would have gotten from Teddy over the last day or so. So you probably see there's probably a little bit more of a bump, maybe 1 or 2 points more on this graph. But you can see the black line is the climatology. And so climatologically speaking, we're pretty close to what you would see in a normal season right now. And we still got, out through the end of November to go. So we're going to add more to this as we go. But you can see the climatological curve really kind of tails off. So we'll have to see kind of how this goes through September, if this is really going to want to kind of pull off or not. But that's kind of where we are. So we got back close to normal in energy usage, and then with the bursts of activity we've had here in the last month of September, we've kind of gotten off of climatology again. This kind of shows where we are for the year, and each storm's how much accumulated energy it developed during its life cycle. I think the other thing you can see is in a lot of these storms, you can see the active dates of being a cyclone are very, very short. Edouard lasted a day. So, we've had quite a few number of storms, but a lot of these really haven't lasted more than a couple of days. And you look at the max winds, in a lot of cases, we haven't gotten even beyond tropical storm conditions. So, I think that's one reason why the accumulated energy values haven't been quite as high. You can see from Teddy, and again, I took it yesterday. So the amount of energy, we were right around for the year so far. Yesterday we were right at 101, and Teddy provided almost a quarter of that energy. Paulette and even Laura, because of how Laura developed so late in the process, as far as going as strong as it did, it didn't develop a lot of the accumulated energy. So, but those three storms account for about 40% of the accumulated energy that was developed in the Atlantic for the year. So, so when you compare it to 2005, there's quite a bit of difference there. Just kind of something to kind of keep in mind as we're looking at this year. Despite it being record-breaking for the number of storms, we haven't really had the really strong, developed storms that we've had in some of the other years, like 2004 and 2005. Some of the things that the Hurricane Center is using and looking at as far as kind of development and forecasts and things like that, and this is where I think a lot of the changes in technology in the last 5 to 10 years have really helped. We're able to really depict a lot better what the water temperatures are, and when they're doing that, they're able to use satellite imagery and things like that, to be able to kind of get some of these readings. If you go back into the late 90s, we had buoys, and that's what we were using with buoy temperatures and maybe some ships that were out there. But now, thanks in part to satellite, more detailed imagery and satellite with some of the GOES changes that have occurred in the last couple of years, we're able to get a lot more detailed in there. And this really does help. It helps tell a picture not only of where some of these storms have gone through, because when a storm goes through an area, you do tend to get some what we call upwelling, where you kind of lower the water temperature because you bring the cooler water that's underneath up to the surface. And I think in this image here, you can kind of see some of that occurred last week with Sally in here, where it sat there for a while. And, so instead of having these plus 30-degree temperatures that we saw earlier in the summer, we're cool. We've cooled it off 3-4 degrees. You can also see the track of Teddy that went through as it got near Bermuda, how it lowered the water temperatures in here. So there's a lot of different details that we can see. We can also see some of the current, that's right off the East Coast. You can see kind of where that warm current comes right up along the East Coast, and that makes a big difference as well. So, as storms are moving through there, they're able to monitor, say, okay, when is the storm going to start moving into cooler water? I know that's going to have an impact to start lowering temperatures and things like that. And typically for the hurricanes, 26C or better, the storm will be able to kind of continue to develop. Once we start getting below that, and especially as you start getting below 20C, the storms are going to weaken because they need that warm water to fuel the thunderstorm activity. This is one of the other things they've started using, and they call it the ASCAT, scatterometer data. And they're getting that off the polar orbiting satellites. So they get kind of two crosses. They get an ascending and descending cross. And this was taken from Laura kind of about a day and a half before landfall. So, but this also helps them get a lot more information as far as what the wind speeds are. Because, outside of recon data before, they didn't really have any being able to figure out what the winds look like. Well, now they do with a lot of this scatterometer data that they're using. And so I think that's helped, especially with some of these weaker storms, be able to go in and actually identify storms that are tropical. Because I think probably 15, 20 years ago, some of these ones that we had that lasted a day and a half, probably never would have been named. They wouldn't have even been identified. They would have, they just would have gone on their merry way. But in this case, with more of the data that we have that's out there, the Hurricane Center can see a lot more of these storms. So I think that's probably one reason why we've had a lot more storms this year, is because of some of the technology of being able to actually identify those type of features now. Recon data is one of the things that the Hurricane Center uses a bunch. This was actually kind of a graphic of a recon flight that was with Beta earlier this week. You can see the plane was taking off from Biloxi, and you can see the wind barbs and wind measurements as it was going along its path. So that's one of the things that we can see, and you can see that stuff real time. There's a lot of different sites that plot that data real time, and I know in Laura they had multiple planes in there at the same time, so they were getting multiple fixes as far as the pressure changes and things like that. So the recon data has been very valuable, and I know the Hurricane Center relies on that a lot for making their decisions as far as strengthening the storms, naming storms, the whole bit. And obviously, satellites, the other big change that's occurred, not only with the scatterometer data, but with what we've seen with GOES, the new GOES imagery that's gone up, goes east and goes west in the last couple of years. They have so many more capabilities on the satellite. The different channels that we can see, from the infrared to the visible to different versions of the visible, different versions of water vapor. You can see mid-level, low-level. I mean, there's so many different things that you can see now with the new satellite data, and they can get it to you much more quickly. It used to be, best we were doing was 15 minutes. Now we can get it in 5-minute intervals, and even potentially even in 1-minute intervals. So you can really start to see development that's occurring, and the images are just better. So I think in some of these cases, with some of the weaker storms, the satellites also help there as well, because you can actually start to identify the swirl earlier and things like that in the imagery. So very valuable. The other things you're able to see, they're able to see the shear a lot better. So when storms are getting impacted by stronger winds aloft and kind of starting to weaken and things like that, it becomes much more obvious with the new satellite imagery. So when you start taking all these different tools together, it really kind of helps explain a little bit why we're identifying some of these storms that in the past maybe, especially as you get back into the early 2000s and the late 1990s, when we had very active years still, but there were probably still some storms out there that we never identified. And part was because, that we didn't have the tools back then that we have now. Kind of the next thing I want to spend a little bit of time on talking about is storm surge. And storm surge has really kind of taken on its own element in the last few years in the tropical program. The Hurricane Center and the Weather Service I think it was 3 years ago in 2017, actually pulled storm surge out of the hurricane warning. So the hurricane warning became a wind warning product only. So storm surge has its own warning now. So and we saw some of that even with some of with just the tropical storm systems, where we were having storm surge warnings at the same time. Even though it wasn't a hurricane, we were still getting storm surge warnings because of the amount of water that even the tropical storms were pushing inland. So I think it was a good change to pull the storm surge out, because it is its own element, and it has there's different things that go in that impact how much water you're going to get. So even in our part of Virginia, with some of the weaker storms, we can still get some significant storm surge. And this was from Hermine in 2016. So this was over on the eastern shore on the Delmarva. They had quite a bit of water there. So if you were in one of those houses, you weren't going anywhere for until that water backed out. So when we're talking about storm surge, what are we talking about? We're looking at a couple different things you can see on the graphic. Typically along the coast, we're going to have 2 high tide cycles during the day on the East Coast, and it varies the range of water, how much that varies. Some cases it may be in the Virginia area, it may be kind of 2 to 4 feet of a water level change between high tide and low tide. You get on the bay, it's less than that. It's maybe 1 to 2 feet. So that's kind of what you're looking at. You get further to the north, up in kind of New York, Massachusetts area, Cape Cod. Some of their tide ranges are 8-10 feet. So you can get, as you change areas along the coast, the amount of your tide range changes, and it does play a factor in the amount of water that you're going to have come in with these systems. Dorian's a prime example in the fact that Dorian got moved a little bit faster as it came through North Carolina and off the Virginia coast, and as a result, the water down at Sewell's Point, down around Norfolk, only got into the moderate range. We were expecting it to hit major flooding with that event, but because it was earlier and we missed the high tide cycle by about 3 hours, it took some of the impact away. So knowing that where you are in the tide cycle really does play a factor. Now, if you're on the Gulf Coast, and a couple of the images we looked at earlier after Sally, you can kind of see they only have 1 high tide cycle a day. So, but again, the difference between their high and low tide really is, within about a foot. So it's not quite as big of a factor as it is on the East Coast. So as you get further north, it's even a bigger factor, because there are times you can get, 6-8 foot of surge into Massachusetts. If it comes in at low tide, it has almost no impact. So knowing where you are in the normal tide is important. The amount of surge is just the amount of water that's being pushed in by the storm, and we're going to look at what impacts that here in a second. So when you add those two values together, that gets you what the total storm tide is. The other factor that's not taken into account by any of these products with the amount of water and things like that is the wave energy that's on top. The wave energy on top, especially kind of within short distance of the coastline, that wave energy can be significant. That's usually what ends up actually causing more of the damage to structures along the coastline. It's not necessarily the water rise; it's the fact that when we put 3 to 4 foot of wave on top of that already rising water level, you start having waves crashing into sides of homes and things like that. Well, they're not built for that kind of force coming in, and eventually that's usually what ends up actually taking down buildings and things like that. So that's the one thing we really can't account for is what that wave energy is going to look like, how big those waves could be once they move inland off, away from the coastline. Okay, so your storm surge factors, and I think, these vary from storm to storm, and I think that, this is what makes sometimes it difficult to necessarily understand why different events have the storm surge forecast. But the intensity of the storm plays a big factor, the wind speed and the pressure. So obviously, the stronger they are, typically the stronger your storm surge is going to be. But that's not always true. The size of the storm is also very important because the larger the storm, the more fetch of water that these winds are blowing over, and the more water that can get pushed to the coast. So if you've got something that's very wide, Hurricane Ike in 2008 devastated Galveston Island with a 30-foot storm surge, and it was not nearly as strong as Katrina. But because it had a longer approach to Galveston and was much wider in expanse, it pushed water inland so early compared to when the center got there. You just continue to build water for hours on end because it covered the entire Gulf of Mexico. So the size of the storm is very, very important. Storm motion is also very, very important. If the storm is moving perpendicular to the coast, you're going to get a much bigger push of water. If it's paralleling the coast, not quite as much. And for us in Virginia in the mid-Atlantic, that seems to typically be more of the factor because most of the storms we see are ones that are moving up the East Coast that are kind of paralleling the coast. So we're not getting the full brunt of water being pushed inland. For those that remember Isabel in 2003, different path. You had a system that was moving southeast to northwest, and that pushed a ton of water into the bay. I grew up in the Baltimore area, and I had never seen flooding in Baltimore City like that from a tropical system like I did with Isabel. So again, it was that angle of approach had a big factor to do with it about pushing water in. And then your forward speed. The forward speed, obviously, usually the faster it's moving, the stronger the push is. So those are just some of your factors. Your coastline is pretty important as well, and this tends to be a factor more inland because when you start getting kind of into some of these bays and estuaries that are inland, we can still see pretty strong surge up those estuaries because of the shape of those rivers and the water being constricted into certain areas and things like that. So that plays a factor into it, and also if you're concave versus convex, you're going to tend to divide the water. Concave, it tends to kind of pool in one area, so you'll get a larger impact there. And then the other impact, the bathymetry off the coast is really important. The continental shelf, you've got a very gentle slope in the Gulf of Mexico, and that allows water to build up more and more, which is why we see these bigger surges on the Gulf of Mexico. Whereas on the Atlantic coast, the shelf is very steep. Once you go a little bit off the coast, it really drops off fast, and because of that, we tend not to see quite as much in the way of surge because there's a little bit more room to be able to house some of that water. So just kind of some additional things to keep in mind. This was a graphic. This was the forecast graphic for Laura, and you can see the expanse of water and how even in some of the estuaries well inland, it was pushing water up. And this is kind of the worst case scenario that they were expecting. But you can see some of those details when you look at this map, as far as compared to where the storm moved. You can see the storm being more perpendicular. We had definitely a larger push. And even some of the areas to the east, when you get over toward Huma there, you can see in some of the tributaries where you had, even over here, you had some larger surge values expected. So again, with the Gulf, with that shallow, sloping, bathymetry, we're able to push a lot more water in. Just for an example, I'm going to take a look now at, what we had expected in Isaias. We did have storm surge warnings down along the North Carolina coast in part of our area. But you can see even here, there's not a whole lot right along the edge of the sound. You're not seeing, any of these areas being shaded in of any really significant surge. But once you get back up to some of the rivers and stuff, you can see where it's doing that. So again, there's a lot of different factors that go in. Obviously, the strength and speed of the storm are a big factor, but there's also a lot of the things going along the coast and things like that go into the storm surge. So, just some things to keep in mind as far as when we start talking about storm surge, what may go into impacting the values that are being forecasted. Last thing I kind of want to talk about a little bit, and this is just something as I've gone around and talked with different people over the years, people still are struggling with the differences between watches and warnings. I think in a lot of cases, it's not something that people think about on a daily basis. So, but when we issue a watch for a product, whether it be a winter storm watch, severe thunderstorm watch, tornado watch, those kind of things, the watch products are just meant to get people to be on alert, to get your radar up that, hey, something's going on weather-wise here that may be significant. I need to start thinking about what I'm going to need to do. I may need to take some early preparations. When we're dealing with tropical systems, we kind of take a preparation a little bit sooner. So, those watches may go out 2 days in advance to kind of get you to start thinking about, okay, we're going to have some strong winds coming in. What things do I need to prepare for? Do I need to, make sure I've got gas for my generator? Do I have objects that could become, projectiles if I leave them out? Things like that. So in watch, if we're dealing with a severe thunderstorm watch, those are typically only coming out, 3 to 6 hours in advance of things coming in. So in those situations, it's more of just kind of getting your attention up so that if something does come out, if we do get a warning that comes out on one of those storms, I know where I'm going to go to get safe. I know where I'm going to be able to protect, my family and things like that. So, the warning phase, when the warning goes out, that's when we need to take action. That's when people need to say, okay, time is now. I need to implement my plan and go, and get myself to where I can protect my life, protect property, and protect the people that I love. Because that's why we're issuing these products, is to to make sure that people know what they need to be doing, when they need to be doing it, so that they're not caught out in weather that's just unbearable. So, and that could be life-threatening. Make sure too that you have different ways to receive your warnings. You need to make sure you have multiple ways, because sometimes the way you normally receive data isn't the same. So whether it be getting to our website, having apps on your phone, the wireless emergency alerts, you'll see those pop up, but those only pop up for specific warnings. A hurricane warning, tornado warning, flash flood warning, and storm surge warning are probably the only 4 that you'll see in the mid-Atlantic region. The other ones that are out there aren't ones that I know that the offices in the mid-Atlantic are going to be issuing those products for. So, so if you're expecting to receive a WIA alert for a severe thunderstorm warning, that's not going to happen. So, at least not right now. So, so the WIA messages are only one way that you can get those warnings. So, look at potential other apps that are out there. NOAA Weather Radio is still playing. And if folks have weather radios, you can set it up so that you get the alarms, the warnings going off for your location. TV still does a great job as far as putting the warning information out there with the crawls and things like that. So you need to have multiple ways, because you're not always in the same place at the same time when a warning is issued. So you want to make sure that you're aware of what's going on around you. And that's why it's important to understand the difference between the watch and the warning. So, because most of the time before you receive a warning, usually there's going to be some sort of a watch in place. Not always, but most of the time. So, again, make sure you're prepared with that so that you know and can take the proper action. And with that, that's everything that I have to share. So we can take questions now.
Okay, we do have time for a few questions. Thanks, Eric. So can you talk a little bit about the role that pressure plays with hurricanes and storm surge?
Generally speaking, I know a lot of what we're using the pressure with, we're using the pressure to help define wind speeds as well. So all of that tends to go in to, the push of water. I know a lot of times as the lower the pressure goes, you start to see a little bit more of a upwelling of the water as well. So you'll tend to draw more water into the system, which also tends to help. So, I think that's kind of where those factors all kind of play together. They're not really individualized. They're more, they all kind of work together.
Do we kind of know why the storm surge with Laura was a little bit less than what was predicted?
I think there were a couple factors there. I think one was, the lack of gauge data played a big factor there. I think if we'd had a gauge a little bit further to the east, we probably would have seen some higher values. And in the long run, we may still find out that we did have those values once they get a chance to do some survey work. But I think the other factors there were the fact that you had a system that was still deepening and hadn't fully maxed out, and a lot of that deepening occurred in the last day or so as it approached the coast. If you'd have had Laura at that strength as it moved by Cuba and had that entire time moving across the Gulf of Mexico, you definitely would have seen a bigger surge value. So, again, timing goes into that. But at the same time, I'll be curious to see what they actually find when they do the high water marking. So, because there was a lot of areas between where their gauges were that were kind of in that eye wall. We're going to see that biggest push of water.
Okay. And because it's 2020, we now apparently have a zombie tropical storm, Paulette. Can you talk a little bit about that, please?
Yeah, Paulette formed about 2.5 weeks ago and moved. It was right after Labor Day when it formed. It moved slowly, or I shouldn't say slowly. It moved kind of west and eventually west-northwest, going by Bermuda early last week. Continued on its path to the north and got up into those cooler waters that we were looking at on that sea surface temperature map. Storm weakened and gradually lost the convection. So once it lost its convection, the Hurricane Center went ahead and kind of classified it as a post-tropical or a extratropical cyclone. But the low level circulation maintained itself. And as it continued to move to the east, eventually it got pushed back down into water that was 25, 26 degrees Celsius. We start to see some convection wrapping around the center again. And at that point, and looking on satellite with the, what we can see on satellite now, the Hurricane Center said we need to start doing statements and reclassify it as a tropical system. So that's why it's now back as Tropical Storm Paulette. And from what I can see in the model, we'll probably deal with it for the next 7 to 10 days out in the Central Atlantic.
All right. So we just have a couple of minutes left. So can you really briefly talk about how climate change is affecting hurricane season?
As far as any particular season goes, I don't know if we can necessarily tie climate change back into it. I think the common thought through a lot of this is because we're getting a little bit warmer, the storms, are more intense. But then when you look at what we were looking at with the ACE data, the cyclone energy data, with the number of storms we've had this year, we're not seeing a correlation there because we're not seeing as much energy because, really outside of 2 storms, we've only had 2 that have hit major hurricanes. So I think sometimes it's hard to pull, a direct link. One of the things I think you can look at this year is when we look at the ENSO cycle, we were coming out of an ENSO neutral period, and we're moving actually into a cooler water phase in the Pacific, which is a La Nina pattern. And when we have the La Nina pattern, it tends to help promote tropical activity in the Atlantic basin because the winds in the tropics tend to be less, so we have less wind shear going on. I think when you start putting different factors together, it's you can kind of see different things having some impact, but I don't think it's necessarily always a one-to-one correlation, not direct correlation.
Okay. So you mentioned the ENSO. That's the El Nino Southern Oscillation?
Yes.
Okay. All right. So I think that's about all we have time for today. Thank you all for joining us. Eric Seymour, thank you for joining us from the National Weather Service. Please join us next week on September 30th at noon. Dr. Tom Ewing from Virginia Tech will be back with us. He will be presenting the search for an influenza vaccine in Virginia during the 1918 epidemic. You can register for next week's talk at smv.org. Each talk is free to attend and is open to the first 300 registrants. Thank you all for joining us today. Until next week, stay safe and stay curious.